He has an English name, Nathan, but he mentioned that he usually don't use it.
Okay.
So I just call him Nat, yeah. So,
Shall we begin? Maybe we can share like the use case first of what kind of data you're bringing in, and also what's the use case for it in Pinot also.
yeah, so the current use case, I think I mentioned to you, right, is mainly about ingesting a lot of our raw data into Pinot. And some of the session and user data sets that I think Srini will be working on, we will be doing the reverse ETL from S3 into Pinot. So we have one stream, the raw events, they'll come via Kafka and sample, and then maybe sample, maybe not sample, but then they will land into Pinot directly from Kafka. And then Daniel is working on that piece.
These data are raw data.
Raw events.
Sent into Pinot, what are they used for?
So this use case is for you to see a sample of the data in real time on the portal, so that people can. There's some use cases that will be on top of it, but not metrics related. It's mainly for you to be able to see your data quickly as it arrives.
What kind of queries should be? Is it aggregation queries?
So far there's only one use case, which is retrieving sample records. But I think there will be more. I think validation on events will be done on.
It won't be an aggregation. It will be like picking just like a reading the entire record or something like that.
Yeah,
but it's not aggregation for sure.
Yeah, so far I think it's record based. You're just reading records out of the database with the help of filters on specific columns. Yeah.
From what I understand is that Pinot works best with aggregations. If you're doing only getting the records out of Pinot, may not be as fast as if you use like a NoSQL database. A SQL database, right? RDS, as compared to Pinot. Pinot may not be the best solution if you're just trying to retrieve records, which doesn't require any aggregations. But even though Pinot can do real-time ingestion, but the reading part of it, if you require low latency, may not be the best solution to do that. It's the same use case as Chopin has a use case also currently, which reads records. They get like tag values also. So it's basically the reading of the record. They're just doing like select whatever columns or distinct values from this column, and then they are filtering those. They're trying to optimize those kind of queries, which is not really Pinot optimized kind of queries. It's just something that you have to consider that may not be efficient enough for your use case.
Okay, so on the records level, right? So actually, I think if you have some stats, right, comparing Pinot and other database that is relevant for this, I think previously actually Jeremy and I were talking about the right way to do this is through Scylla, but then I think or Scylla or something like DynamoDB or one of the two, right? But I think we weren't. I think SN is keen on putting into Pinot, but if you have some data on like comparing just retrieving records in Pinot versus
from what I understand from, I never really do any benchmark, but what I understand from LVs, they have previously, for their phone, they're using Kairos DB, time series database.
Okay.
They see relatively good latency, just that because there is not much use case of Kairos. So they only one user, which is therefore they want to deprecate Kairos. Right. So and they move to Pinot. Because Pinot usually superset wants to retrieve matrix from lake and display the matrix faster in superset. So they move this matrix over to Pinot.
I see. Most of the time series database is for the aggregation, like for the aggregations and do some metrics, right?
Yeah, correct.
I think our use case is not exactly aggregations.
Yeah, it's really just pulling records.
Yeah,
for
pulling
this.
So it's like a key, for a given key, we'll pull the record, something like that.
Correct.
So we'll give the session ID or something. We'll give we'll pull all the events from that particular session ID.
But the session one, I think session and user potentially should be in Pinot because there are some metrics you can build on top of it. But the raw data, right? The raw data is really more or less, even when I was discussing with Daniel, right, the requirements is really just pull the record given a key. Yeah. So
Then if everything is a key, then why not like a NoSQL database where your key is actually the session ID key?
I think that will work also, but there's another consideration that Esan also mentioned, which is he doesn't want to maintain extra infra, and we want to do something that is
so like
out there.
Y'all can most likely discuss again with the Choban team, which also will maintain the Pinot infra for you guys to explore maybe other options that are non-metric related kind of queries.
Okay.
I don't think like just retrieving a huge amount of data from Pinot is fast, because Pinot is retrieving huge amount of data from the servers and then aggregating on it and then sending out. That's where it's performed the best. But just retrieving huge amount of data and then sending the huge amount of data out to you guys maybe slow.
Okay, so I think maybe then the event records one, we'll see we talk to Fabrice again. Now on the session and user one, right, I think those are probably, I think it makes sense to because you need to run queries. There will be metrics built out there.
The table, like for example, the table that Jeremy brought into Pinot, is that was the one of the table
event metrics.
That's event metric.
That's event metrics, yeah.
So that probably isn't So actually no, now that you mentioned this, right? So yes, actually there is one metric that we will put on the records level. And that's the event count by key. That's the only metric that we need to pull from the event level data set. Yes. So we will be counting by key. Yeah, I think that's the only metric we will have on top of the event level data set. Okay. And ideally, once that is done, right, we don't do the pre-aggregated version that we have right now in Pinot. That means we don't go and aggregate in S3. I mean, aggregate in the data lake, write to some place in S3, and then reverse ETL into Pinot. That's the current metrics table.
Okay.
Yeah.
I think that will have a issue, like we have to retain a longer data, right, to get the example, even if you take the 40 days, like 30 days, last 30 days trend also for the event, we have to retain the data in a Pinot for 30 days, right? I don't know if that is a way, especially for the event metric one. Maybe there could be some other better way we might need to explore.
Can we write the metric somewhere from Pinot after we aggregate?
No, you can't. Limitation, what stays in Pinot will stay in Pinot. The only way to read it out from it is you actually directly query the data out from it.
So yeah, let's say I query the count for a key for a specific day. Can I can write it somewhere and then put it back in Pinot?
You can also, but
that's what Jeremy is doing.
No.
Exactly.
In Spark.
The second one.
Okay, so right now you're saying that your pre-aggregate the data before bringing it to Pinot. That is the current way that Jeremy is doing? Or?
Yes.
Yeah,
I think he's doing some partial aggregation somewhere.
Okay.
And he's doing that's a partial aggregation, and using Pinot, he's doing even more fully aggregation based.
I see. That is also one way to do it. Yeah.
I mean, that's what it will end up saying what Jeremy is doing.
Yeah, he's doing it currently from the lake after track events, right? So the goal here is that if we have the events already in the DB records wise, we can count in 10 minutes. I think the latency will be much shorter. We can show you the counts earlier. I think I think that's the only metric that we'll probably be using on top of the events dataset.
Okay.
It makes sense to put in Pinot.
Count, aggregation itself is makes sense to put into Pinot. Yeah.
If not events, maybe we can definitely look at the session side of it, right? Sessions are definitely it's not that much, but most of the time we do the aggregations, in a particular session, how many number of crashes happen, how many number of people visited this page or something like that. So there can be a lot of derived things, if different dimensions in one particular record. That will be definitely.
Yeah. So those kind of queries is suitable for Pinot, but I'm just thinking of ROI of you only having one kind of query, because Pinot is also very expensive. So you have to validate what is the ROI of actually putting into Pinot.
I think maybe then can we have some kind of rough estimation, say for example, maybe Nat or Daniel put the data into the Pinot and then see how much it costs. So if we have this cost number, so then we can go and speak to BTS or whoever.
Okay, yeah, so I think you can try it out. I also highly suggest that you talk to Choban team because, okay, so from the story or the vague story that I get from Elvis, which is working mainly on Pinot or therefore, they stay on Pinot because superset require Pinot. So they want to maintain a Pinot cluster. They want to deprecate Kairos because only one user is on Kairos. The ROI to maintain the cluster is not high. So right now, superset left already. Superset went to use Starbucks. So they only left with their phone. And then now Scribe wants to bring in real-time data into Pinot. So the ROI of Pinot to maintain Pinot is high. Right. So right now they have a reason of maintaining Pinot. So if you all require this kind of use case, maybe Kairos or maintaining Kairos is the way to go.
Oh, okay. We will do some.
You should have to check
check with Chobati.
Anyway, the Kairos DB is currently still there. They haven't fully switched over to Pinot yet. They also understanding how Pinot work and how to ingest and how the queries in. Yeah, they're also doing aggregations also in Kairos also.
Who is looking into this?
Elvis. But he's working more for the POC or linkage. You can also talk to Min.
Okay. Min. Can you send to me? I'll share with the team. Okay. I think we have around another half an hour, right?
I think I can still walk through the Pinot injection with you guys.
Yeah.
Is that what you prefer for this session?
Correct. Yeah. I think let's try and walk through the Pinot ingestion. There's two parts of it. I think we need to figure out. We need to have a demo for the Kafka side of ingestion, from Kafka into our own cluster. And the
Kafka into your own cluster. You mean the cluster maintained by Chobati? Okay.
Yeah. And then the other one is from S3 into that cluster.
S3 into that cluster.
Yeah, Srini mentioned there's a Spark library to do this.
Yeah, there's a Spark library to do this. Maybe we today focus on the real-time person because that's what you actually immediately need, right?
Actually, we should. I would love to have both because one's working on real-time, one's working on the offline.
I think the offline one we can create different sessions. It's not because I don't handle the offline batch injection. It's by Zhengfei.
It's by Zhengfei.
Yeah, Zhengfei is the one I can see in also, but it's a different session that he set up everything for the batch injection. Yeah.
Okay.
So Pinot architecture kind of looks like this. Like this. You have this is a very big one. This is the user that sends in queries, right? You have your broker and controller. Broker is the one that have the routing table and maintains all the queries, and then you will forward the queries over to the servers, and then the servers will send back the data over to the broker. Broker will aggregate and then send it back to the user. Simple architecture. So you talk about when you zoom into the injection part. The servers are the one that receive the data. So the controller has a helix inside that tells the servers which kind of partitions you're supposed to consume or what kind of segments you're supposed to download from the deep store. Right? There is this concept of deep store that is actually S3, where it stores all the segments. So segments is like your, what do you call it? The smallest unit of data in Pinot. There are like files that keep a bunch of records. It's just a subset of records of a table. So you have segments that are in Pinot. So when the servers, you have this in a, I can show you one example. So first you do is that you define a schema in Pinot. Takes a while to load. Stop me anytime. I'm trying to fling this.
When you say define a schema, right? So let's say the cluster is owned by Choban. Can we define it, or we need to go through Choban and define it?
So ideally, you maintain your own YAML schema in a GitLab repo and then push it. But that setup is not yet done in Choban. For Midas, we already set it up already. So we have a GitLab CI that push these YAML files over to the cluster itself. but they haven't do it. So
it will spin up a new cluster.
They already have a new cluster. So this is the Chopan cluster. Staging Viper is the cluster.
Adding the GitLab, the schema will create a new cluster, or it will
currently,
create a new table
no.
in the existing cluster?
Currently, no. They are, the only way that you can edit is to edit directly onto the DB itself.
Okay.
So the DB, this is the list of APIs that they have. You can add a schema, add a new schema. So you have to add the schema first. This is much more flexible than you adding via the UI.
Okay.
So in the UI, you can add a schema here, which is very structured, but it's easier if you add via a JSON file. And then, for example, the schema will say it's split into 3 different kind of fields: the dimension fields, the metric fields, and also the datetime field. Metric field is optional, but dimension and datetime is compulsory. So you kind of like, you can be a subset of your schema in Kafka. So you just state the fields that you require. So after you set up your schema already, now next is the table config, right? So the table config, if the main difference between the real-time and the offline is actually this injection config here. So if you zoom into the injection config, you can see the stream type is Kafka. The topic name is the Kafka topic that you're using, and also the broker. And then the offset reset is, there's a retention in Kafka, right, that you specify for n. If you do smallest, you will read from the smallest offset of the Kafka retention. So from the earliest message, but that consumes a lot of resources. So we tend not to use that unless you require backfill or something. And then we use largest, so it's the smaller of largest. Kafka consumer type, usually we use low level, which helps it to maintain the same partition as Kafka. So Kafka has 5 partitions. Then Pinot will spin up 5 different consumers to read from these 5 partitions. Each consumer will be 1 partition. Then apart from that, there's a decoder versus URL that reads from Confluent. This is
the schema.
So in Grab, we are using descriptor files, right? We do not use Confluent to serialize and deserialize our data. We're using descriptor files. That is the way that Grab goes. But in Pinot, there's a nice way that you don't have to maintain descriptor files. So in Midas cluster, we pull these descriptor files from the schema repo that Choban maintained. I mean, most likely your schemas are also in that repo. We pull the descriptor file from there, pull into local of each server, then we link it. So, show you an example of what we do. This is our cluster. For us, we do this way. Here, so you have a descriptor file that you link instead of URL. Just now that the other config was a URL. This is a descriptor file that you point to the descriptor file that you are actually using to deserialize, right? There's another way of having it on the Confluent registry. So I think this is the way that Choban currently do. So what you have to do is that your Kafka topic, you have to have a Flink pipeline to serialize the Kafka topic with the descriptor file, or you have to push the descriptor file up to the Confluent schema registry. Also, Choban also has it, that's not widely used. Use that schema registry to serialize your data, and then push it into the new Kafka topic. And then you read from here, and then you can point with the URL. This is currently the way Choban does it.
I see.
Okay, this is slightly different. Additional step that you have to do. Then, this is the flush threshold and the flush threshold size. So, flush is that segment when I'm consuming a segment. I'm consuming data from Kafka, right? I'm keeping them in memory first until a particular threshold hits the threshold. I will flush this data into memory, into local disk. Then after that, I will make a copy in the deep store. Okay, so the consuming segments, there are 3 kinds: consuming segments and completed segments. Completed segments are being flushed. Consuming segments are being memory. Right? Consuming segments can still be served by the server. So I'm consuming data in real time, right? I'm still able to serve this data in real time now. So only when they are actually flushed to this, then I will persist them into deep store for backup. Okay.
Okay. Can this data modify, say for example, is it like append only kind of thing, or like can it even do the merging of the data Say for example.
So there are different kind of injection kind. There's the normal append injection, which is the most straightforward. There are also dedupe, upsert.
Okay.
But these two are expensive because upsert you need to maintain the hash map in memory, so that's expensive. So this kind of consideration have to consider. If you're only ingesting data from real time, then you really just append only.
I see. Okay.
Then there is another configuration called transform config. That basically you can do simple transformation of your data into Pinot.
Okay.
So for example,
time.
Let's say host, right? This is the column name of what you define in the schema in your table. So your table you define host string, right, in the schema, but in the descriptor file in your Kafka topic schema, it's actually there's a nested JSON. It is data points first as a class, then followed by host as a string type. Then you have to access or you tell the injection that it's actually nested. So you just use this to get to the nested fields.
Okay.
Or let's say another way of it is not called host. Maybe it's called host ID.
Yeah.
But you want it to be
host
called host name.
Yeah.
But we have to call it you need to be called host in Pinot. So you put this as host, and then you put this as host name. So it will map host name from Kafka over to host in your own schema.
Correct.
So you have this transform config, or you can do like case whens, this kind of stuff.
Like a basic functions.
Basic functions, yeah, correct.
Yeah.
These are Pinot supported, or is this the Kafka transformations?
I think this is from the Pinot.
This is from Pinot. So these are you ingest from.
It's like, for example, the logic you write in the transform function, right?
Yep.
Is the syntax Pinot syntax, or is it the Kafka?
I think it's a Pinot syntax. No, it's a Pinot syntax.
Pinot syntax.
Because I think if I understand correctly, this Kafka consumer is running inside Pinot.
Yeah.
Is it Pinot server?
Yes.
Inside servers. Yeah, inside servers.
Okay, got it. Okay.
This is how a segment looks like. So a segment, this means that right now, we are diving into. So there's a replication. So the retention is the dice that you want to retain, and then there's also a time column that is fixed to it. Usually for every time you use event time or updated time, which is the record time. And then replica per partition means every single partition, how many replicas you want to have. So right now it means that every single partition, I want 2 consumers to be consuming from this partition. Yeah, for redundancy. And then if you look into each segment, it should have 2. Right. Yeah. What else? Yeah, I think that's all for the ingestion, I think.
And the query, the user queries will be serving via. Could you show me the Excel once again?
Sorry, what thing?
Excel you are showing about the servers running from the Pinot, right? The user's query will be hitting the broker.
Yeah.
Okay. Is it possible to modify so if I understand correctly, you said if the data has to be modified, say for example transaction, like let's say for example booking, like the booking confirmed for a booking event, if I want to put it in a Pinot, booking confirmed, but maybe after some time the booking got cancelled by whoever the reason, right?
Yeah.
So the same booking ID need to be updated. So in that scenario, can Pinot allow us to do these modifications on the record, even though the data is in a deep store, or is it only in the in-memory one?
Oh, I see. Okay. When data are flushed into this, that means you already completed the segment already. You cannot modify it.
Oh, we cannot modify it.
Modify it.
I remember reading that you can upsert, right? And then Pinot will read the latest time, right? So I think you can upsert. So if it's still in memory, you can upsert, but that's expensive, right? But then if it's flash restore, it's like you read record keys that is the latest record time or something like that.
So we have upsert tables as well. For now, Midas, we make a restriction that you can only keep for 2 days, because the amount of memory that it consumes may potentially be high. So we need to keep it for 2 days only for retention, which is very small. But usually upsert data, you have a closed booking state, right? Like you will expect that the booking should be closed after a certain amount of period. That's a window, right? Actually, 2 days is actually more than sufficient from what we understand from the use case for market watch. So we keep it for 2 days. Then this data can be moved somewhere else, which I can explain further later. So like for an upset, it requires your Kafka to be partitioned by that key first. That is the first requirement. So Pinot don't do the partitioning for you. Yep. So that let's say session ID is the key that you want to upset by, right? So you need to key in
session ID first.
In Kafka first. So you need a Flink pipeline to key so that it will be hash and then it will be deterministic that every single session value goes to a single partition. It doesn't spread across multiple partitions. You move there, then you specify in Pinot that this is a second partition config, that you have a partition on, let's say here is order ID, right? Then you mention this, and Pinot will know that, okay, I have an order ID, I need to keep track of this in my segment metadata. So it knows that every single segment, this is the range of order IDs that I am currently keeping in within my segment. As this metadata involved in segment level, then it will know that every single segment or every single server, because a server will tie to a partition no matter what. So it only consumes and maintains. So the map that it has to maintain is per partition. No two servers will share the same partition unless it's a replication. They won't share like maybe partition 1 shared by a lot of servers, no. Right? Not the upset will not work. Yeah. So they will keep this information. Yeah.
So if I understand, so basically you keep everything in memory for 2 days and you keep asserting and then you finally sync it after 2 days.
Okay, so it brings us to the next thing. So right now, what retention that you see here is the retention of the table. Okay. There's a different thing there. So there's another way of doing is that there is this real-time to offline flow. This is a real-time table, this is an offline table, right? Offline table you can't do upset. Only real-time table you can do upset because you're consuming records and then you're upsetting within the memory, right? Offline table you don't do upset. So this combination, booking V3 real-time, booking V3 offline, they are a hybrid table. So hybrid tables are same name, same table name, but the suffix is different and it's only real-time or offline. So if you query as booking V3, you're actually underlying querying the real-time and offline based on a particular time boundary. So a time boundary is a fixed time that if my time range is, let's say 2 days, my real-time table is only 1 day retention, but my offline table is, let's say 10 days retention. If I'm querying for the past 5 days, you will know that the first 1 day, I'm going to query the real-time. The last 4 days, I'm going to query the offline. Okay, so this is the real-time to offline. This is a task internally in Pinot that it will flow the data from real-time to offline.
Okay.
Yeah, and so for the upset, for real-time upset, as you mentioned, if you design it to be upset of 2 days, correct? So it will keep upsetting in the 2 days, but if let's say you can move these 2 days after these 2 days, you can move this data over to the offline table.
I see.
To be safe. But this offline table need to know that it's not being upsetted. Okay. Only the 2 days window is upsetted.
Okay.
Yeah.
Okay. But in terms of how this works, it's just you change the table configuration, is it?
So in the real-time table, there is all these are the same. Just what we mentioned about the real-time stuff. There is this special config called here, a task. So this task is the real-time to offline segment task. What is this saying is that you have a buffer time period. That means only records based on the main time column of this real-time table, only records that are after 2 days or after the buffer time period, then I will start considering them to be moved into the offline table. So right now here is 2 days. So the records now minus 2 days will be moved. Right now it's moving it to the offline table, and I'm doing concat. I can do other stuff like merge or like aggregate, so I can like batch it. I can further pre-aggregate if I don't need like older data. I need just pre-aggregation. I don't need like milliseconds kind of granularity. I can batch it. Then max number is the the threshold of each segment. Don't need to be too big, don't need to be too small, right? And then the schedule is the how often you want these tasks to be run, right? And then the bucket time period is saying that there's also another use case is that right now real-time data coming in, and the threshold you're saying like every 6 hours I want to flush, or if the segment size hits maybe 4 gigs, I want it to be flushed, right? It's not really time-based. It's more like real-time. I would say it's like overlap. You have a lot of overlap of segments. It's not like 1 hour, one segment. It's not like natural time bound based. So this one allows you to allow it to have the fixed time boundary of every 1 hour of segments. Help me create a segment of this 1 hour.
Okay, I see.
Yeah.
Okay. Okay, wait, so summarizing right so far, right? So in terms of S3 or Kafka ingestion, it's more or less you need to write the correct config. So you define your table schema first, then define any transformation logic you need from your Kafka into the respective columns in the node.
Yeah.
And then set up some of this configuration on retention.
So a lot of these things are similar. All of these, like table index, and all these are similar. It's shared between them. The main difference actually is just this one, the ingestion config. So a batch ingestion will not have stream ingestion config, it will be batch ingestion config, right? They have their corresponding one, which will points. The heavy lifting is not done here. The heavy lift, because this Pinot does the heavy lifting for you for ingestion. For offline, you need to have a Spark and a Spark connect. This is a Spark library to build the segments. So it's a different architecture which you can cover another day, but the general idea is that the Spark, the jar file will build the segments, push to deep store, then server will pull it down. It's a different way.
Oh, I see.
Different way.
I see.
It's other way around. Okay.
Kafka is like this.
Metadata comes to the Pinot, and the other one will be directly going to the deep store.
Yeah. So three different architecture. Yeah.
Okay, understand. Okay, so I think we covered the stream one in here. The offline one we need to set up one with Chongfei.
Yeah, we can set it online.
So in that case, can Spark modify the deep store? I think I'm always going to the modification because we will be, our data is not continuous. Sometimes because example sessions, right? If you want to keep the sessions in some kind of place, this data will be bound to modify. It cannot be consistent. Our data is not a fixed one.
Yes.
So the deep store data can be modified.
Yes.
Okay.
You can modify that?
That's okay. No, you can't.
Right.
So what we do right now is that upstream always modify, right? Lake always modify, right? What we do is you modify,
and you
re-inject, recreate.
Okay.
So our stack is we have anomaly. What's it called? Airflow. Anomaly.
Yes.
Anomaly will schedule the job which runs the Spark connector, and then we just like user tell us that, oh, my data changed last month, help me backfill for the last 3 months. Then we just run the Airflow job to re-ingest every single thing into Pinot, and then you will re-ingest everything into Pinot, deleting the old segments. You will replace.
Oh, I think okay.
Right now we will just do a hard replace of every single segment.
Yes.
Okay.
I still couldn't find a perfect database, man.
I feel like, I mean, you're looking for one that can read S3 directly, right?
Starbucks.
Is it good?
Yeah. But I don't know the latency. Currently, we also exploring Starbucks for our offline matrix. But y'all can try to play around. You still
I think maybe Cassandra seems to be good, but Cassandra has a lot of like a Scylla.
Scylla. So Scylla for event records. I think event records are hard. Our restriction is mainly write. And then after that, we only need to largely...
The reads are not that much actually.
Yeah, we're going to read like key value for short amount, and the only migration we're going to do is count, most likely. Yeah.
I don't know, man. Let's explore DynamoDB, how much it costs. I think it shouldn't cost too much, man.
But okay, but before we change on this, right? I think we should
continue. Daniel, nothing for you. This is out of the blue. Whatever I said, don't consider it as a serious thing.
Yeah. So Daniel, in terms of stream ingestion, right? Do you have any questions on the config that you see here, and how do you need to do this for Kafka ingestion into Pinot?
I think that's all.
Okay. I have one though. Like, if we need to, because I think if we're gonna keep this infra, as in like continue to use this on our side, I think the repo route makes a lot of sense. Set up a repo to do CI and push to.
Yes, which also is also that you require a repo to maintain the version.
Yeah. And the pushing wise is actually you're calling the API in your CI.
Yeah, just call it API. Yeah, it's the same thing as Swagger. What you do in Swagger, you just call the API.
Okay. Yeah. And then they just version the repo basically, and then keep it in sync.
Pinot don't keep it version. You need to version it you like yourself.
Okay. Yeah. Got it. And then we just so the CI process, every time we change, we maybe div, maybe don't div, whatever, and just push the new config to the cluster by API, right?
Yeah.
Okay. And the repo wise, it has to be from Global Stack, right? Because they own the cluster.
I don't know how they gonna. I feel like they should own it.
Okay.
If not, they will no idea what is being ingested into their. They should have some deployment flow for that also, instead of just doing for everything.
It was so strange, because now we're the only one using this cluster, and it's effectively almost we're like the biggest customer.
Yeah.
Of this. Okay. Can we'll figure out with them like.
Okay. And small maybe side stuff is that you all can play around with indexes. So if you say that you do a lot of filters, so equality or in filters, you can use inverted index. And then range, or you just put if like range or random time or whatever range kind of filters you're doing, then you put in the range index. Yeah.
You can check these, right, in the Pinot config. What sort of index they have?
It's all there. Yeah.
Okay. Got it. Okay. So I think Daniel, I think for now let's focus on setting up the base stream config that we can put our Kafka data into this cluster. Don't think about the indexes and all these things first. We'll focus on the retention and replication and just the schema and stuff, so that we can see the data coming in from staging. We'll figure out the indexes after.
Yeah, I got it.
Cool. I think from that, right, I think we'll need to schedule another one with Zheng Fei on how to ingest from S3. But based on what we just talked about, right, Jason just shared, right, it will be an Airflow job that runs some Spark, that uses some existing Spark library to create the segments. So you read from S3 via that Spark library and write to the Pinot deep stock, right? Yeah, so that one we will. I think you can familiarize yourself with our Airflow cluster first. I'll share with you, and then we'll set up another time with Zheng Fei. Okay.
I think I'll give a talk with Choban team on the queries that you're sending also, and see whether maybe we can explore both in parallel with Ross also.
Okay. Ken, I think that's all.
Okay.
Thanks, Jason.
Yeah, no problem.
Anything?
No, all good. Yeah.
All good. Okay. Thanks, everyone.
Think so.
Thank you, everyone. Bye.
Let's write our own database, man.
No way, man.
No, man, that's not complicated, man. There are big.
Why your own database? Don't maintain your own database.
Yeah,
I really.
I don't know, man. It sounds pretty. I mean, I don't know how.